Hello students, this video is designed to help with the Unit 11 problem sets. We're going to take a look at all the problem sets from Unit 11, including composite shapes, looking at area and volume, and we're also going to be looking at density problems. If you haven't already done so, please pause the video and try the problem sets, and then come back and check your answers. Alright, the first couple of problems were all composite shapes. That's either two shapes that you have to subtract. In this case, we had to subtract the circle from the rectangle or the square here. In this case, we had to do the same thing. We subtracted each of the circles areas from the square. In this case, we subtracted the triangle from the circle, and every shaded area or shaded portion question pretty much is going to be subtracting too. In this case, it was two shapes that were put together. This is a rectangle and a semicircle. We found the individual areas and we added them together. And then it asks us, well, if 1 can of paint contains 500 square feet of paint, what can we do to cover the whole court? How many cans do we need? Well, the whole court is only 105 square feet, so we don't need more than 1 can of paint. This is a very similar type of question. It asks us to do two shapes subtracted from each other. Here's another one where it's two shapes, except this first shape is a square, and the second shape is actually a semicircle. Easy to find out, though, because a semicircle is just 1/2 times pi r squared. Here's another semicircle. We found the two areas, and we added them together because we're combining. In this case, there's a shaded region, so we're subtracting. One interesting thing to note here, the area of 4 quarter circles, 1, 2, 3, 4, well, there's 4 quarter circles, which means 4 times 1/4. Those eliminate, so we didn't have to worry about doing that. We could have just said, well, all of these 4 quarter circles make one whole circle. On the next page, lesson 2 problem set, these are the correct answers, and in every case, we just use the correct volume formula. In this case, we're using 2 different volume formulas because we're asked if the 2 volumes are equal, which means we have to find the first volume and plug it into the second equation. What is the height? And that means we solve for the height. Number 6 was a little tricky because it tells us there's a rectangular tank that measures 5 by 4 by 3, but it says water's only poured into the tank to a depth of 2.5 feet. So we're not using 3 feet high, we're using 2.5 feet high. But 5 feet long and 4 feet wide are exactly the same. So that's where we get that 50. Most of these questions are just plug into the formula and solve. For number 8, it was a little bit different because it asks us to find the volume of a tank and then asks us to set up a proportion. 2 hours for 1 liter, that's what it says here, is equal to X hours over 3 liters. And you had to know that 1,000 cubic centimeters is the same as 1 liter. That's what it said here. For question number 9, you found the volume of the cylinder, you found the volume of the tub, and you divided it to figure out how many cups fit into the tub. I would pour 34.3774 cups in order to fill it. Well, if I only pour in 34, that's not enough because I need 0.3774 more, so I can't fill up the cup halfway. I have to need 35 cups. And in this last one, it gives us a question about 2 cylinders that have the same bases but different heights, and they're all jumbled up. Well, the same height, but they're all jumbled up. As long as the bases are the same and the heights are the same, then the volumes are going to be equal. That's Cavalier's principle. You will see that on your test. The problem set for lesson number 3, it asks us to figure out what's going on with the amount of wax. In other words, the volume for the wax. The first thing that they gave us is the circumference, and the circumference is equal to pi times diameter, which means that back solve to get diameter is equal to 10. Then I use my volume formula for a cone, keeping in mind that the radius here should be 5, not 10, because radius is half of the diameter. For question number 2, it didn't ask us to find an actual answer, it just gave us a setup. So we're given a cube, and then we're told a cone is going to be cut out of it. So we're doing this volume of the cube minus this volume of the cone. For number 3, we were asked to find the volume of the pyramid. This is just a plug-in problem, shouldn't be that difficult. For question 4, it asks us about the volume of a pyramid. It tells us the perimeter of a base. Well, it's a square base, and 36 inches as a perimeter means that each of these sides is 9. In other words, 36 divided by 4, because they're all the same size sides, is equal to 9 inches. Then we just plug it into the formula. No big surprise. I've been saying plug-in for the last couple of times, but plug-in, of course, is the thing that you do to your hairdryer. You're supposed to be substituting. The regular pyramid with a square base is shown in the diagram. Here's the pyramid formula. No big surprises here. For question number 6, This was a conceptual question. It asks us about the volume of a cone versus the volume of a cylinder. A cone is always a third of the volume of a cylinder, and here's the proof. The volume formula for a cone is exactly the same as the volume formula for a cylinder, except cone's got this 1/3 in it, and cylinder does not. So the water will reach a third of the way up in the cup. The base of a rectangular pyramid has a width and length of 6 and 8 respectively. We substitute them into the formula, and they gave us the volume, which is 288. We put that in for volume, and then back solve, or just simply solve, to find h, that is the height. For lesson number 4, they give us the diameter of a sphere. Remember, they're going to give you diameter, but you need to convert that into radius. That's going to be half of the diameter. Substituting into the equation should get you the correct answer. Now keep in mind, in this problem it says 10.6480 is equal to r to the third. We need to solve for r, so in other words we need to use our cube root. So what I'm going to do is I'm going to take 10.6480 and I'm going to cube root it. It's not square root, which is this button down here. It's you have to go into the math menu. You have to go to where it says the cube root, so press enter there, and then we're going to punch in 10.4680. Now keep in mind, 6480. Keep in mind that in all of the cases that it's asking me to round eventually to the nearest tenth of a centimeter, I'm taking it to 4 decimal places. So inside my calculations, I'm going to take it to 4 decimal places, but as my final answer, I'm going to do what it says, to round to the nearest tenth of a centimeter. This answer should be 2.2. 2.19 repeating, which is a very straightforward answer. All right, moving right along, we're taking a look at the basketball problem. Again, it gives us a circumference. Circumference, I just substituted into the formula for circumference, and I get my diameter, which is 9.3. Cutting that in half gives me the radius. And then I substitute radius into my formula. This is not a big deal. The volleyball problem gives us 2 different volleyballs and says, well, this volleyball has 180 inches cubed inside of it as its volume, and this one has 294. We simply solve both of them to find the 2 radii, and it asks us what's the difference, how much does the radius increase? It increased by 0.6. No big deal. In this case, there was a quick way to solve it. It says circumference is 13 inches, which means the diameter is going to be 4.1380 inches. I just divided both sides by pi. Once I know this, I don't need to do anything else, because once I know the diameter is 4.138, that means it can't fit into a box that is 4 inches on each side, because there's 0.1380 inches that are going to be left over. That means the box's sides have to be at least 5 inches. Moving right along, the satellite is in the shape of a cylinder with 2 hemispheres. Well, if it's got 2 hemispheres, 2 half spheres, that 2 and that 1/2 is going to eliminate, and all I have left is 4/3 pi and the radius cubed. In this case, the diameter is 2, which means the radius is 1, so 4/3 pi is my volume for the hemispheres. The volume for the cylinder is here, and when you need the volume for the total, we take those 2 and add them together. It says express the answer in terms of pi, so no rounding is going on. I don't put pi in my calculator, I just put the numbers in the calculator and find the answer. The storage tank here is 1 hemisphere and 1 cylinder. I found the volume of the hemisphere, the volume of the cylinder, and I added them together. This should not be too difficult. These are 4 different volume formulas. Remember that you're going to get the volume formulas on the test. In fact, here is the reference sheet, the exact reference sheet that you're going to get. It has a bunch of different volume formulas, so you don't need to memorize these volume formulas, just know how to use them. Again, this capital B is the area of the base, the R is the radius, the H is the height, we already talked about R, D is the diameter, so these are pretty straightforward things. Where were we at? I think we were here. Oh, we did this already, great. So, question number 1, I think this is the last problem set that you had to do. It gives us a couple of pieces of information about the rectangular prism, so we found the volume. And then if we know that the weight is 0.25 pounds per cubic foot, well, this is cubic feet, so I'm going to multiply this by 0.25. 102 pounds is my answer. Let's see, it gives us the density of the American white oak is 752 kilograms per cubic meter. That's going to be over here. I just changed that to say kilograms rather than grams. But before we get into this, we need to find a couple of things. First, they give us a circumference. Well, circumference is used to find the diameter, which is used to find the radius, which is used to find the volume of a cylinder. And why am I using cylinder? Well, it's a tree trunk. Tree trunks look like cylinders. Here's my volume, which is 12.8916 cubic meters. That means I can substitute that into my density proportion. I have kilograms on the top, meters cubed on the bottom, so I need to find the approximate number of kilograms, the approximate weight, so I'm doing X kilograms over 12.8916 cubic meters, and then I cross multiply to get 9,694 kilograms. A very heavy tree, in my opinion. Here we're finding the volume of a sphere, and if we know that it's 0.075 pounds per cubic inch, that means we're multiplying the amount of cubic inches by the amount of pounds per cubic inch. It's about 20 pounds. Not that heavy. For this one, it was a hemispherical tank, so here's a Hemisphere Formula. It's the 1/2 times 4/3 pi r cubed that we're familiar with. And if it's 62.4 pounds per cubic foot, that means we're multiplying our volume, the cubic feet, by this number, which is the number of pounds per. So that's 16,336 pounds. Heavy water. This is the same exact question. So we're moving on. This is probably the most difficult type of question. It required you to know that 1 pound is equal to 16 ounces and 1 gallon is 3.785 liters. And you might be saying, well, that's not fair. How am I supposed to know that? Let's look back at the reference sheet, shall we? We have a couple of pieces of information, including 1 gallon is equal to 3.785 liters. So it seems like this is fair information for you. It also tells us the conversion between gallons and quarts and pints, etc. So you should be able to look for this and say, oh, well, 1 liter, how much is that? Well, it's 0.264 gallons. These are given to you. They're not mysterious measurements. All right, we do the cross multiplication. We have ounces over liters. So we find X, which is the number of liters, and then we need to convert that into gallons by dividing it by 3.785. I could also multiply it by that conversion factor, which is 0.264, but I like dividing. Dividing is my favorite. Question number 7, it gives us population densities and populations. In order to find the area, in order to find this miles squared, we need to take the population, the people, and divide by the density. So we did that 4 times. We got 55,519. That's the largest one. It says from largest to smallest. So here's Illinois is the largest. The next largest is Florida with 53,626. The next largest is New York with 47,125, and bringing up the rear is Pennsylvania with 44,742. All we needed to do was find the area, which is miles squared, by converting population and population density into area. And last but not least, this was a question that we did in class, and that question asks us to figure out the price of 500 of these parts. Well, first we need to find how much one part weighs. That's this density calculation here. We cross multiply in order to get 8,069.25 grams. That's the weight of one part, which means I need 500 of those. So I multiply the weight of one part times 500 and I get this total. This is the total number of grams. Well, if you didn't know, a kilogram, which is what we're talking about here, 0.29 or 29 cents per kilogram, a kilogram is 1,000 grams, which means I got to take this number and divide it by 1,000 to get the number of kilograms. This is something that I should have mentioned in class. And then last but not least, we have the price per kilogram. Well, if this much money per kilogram, then I got to multiply that times the number of kilograms. And then I get $1,170 rounded to the nearest dollar. All right, this was a review of the problem sets from Unit 11. Good luck studying.